Hey guys, IT Guy Michael here and welcome to another lecture of our course about classification in Python. Now this video is a little bit different to the others of this course. I'm going to talk a little bit about algorithms which we use for the classification in this course. Now, to make things clear, there are like dozens and hundreds of algorithms which are applied today to predict the classification. Right, in this video, I'm gonna just talk about k-nearest neighbors classifier and just a little bit about logistic regression. Now, there are even other stuff like the Bayesian classifier or the neural networks. There are various types of neural networks, the deep networks, deep neural networks, XGBoost, random forest, and classifier trees, for example. Now, if you are interested in other classifiers, please go to the internet and try to look something there. There are a lot of great tutorials on the internet. I've referred to some of the tutorials during this video. Now, as I said in the previous video, I don't want to make this theoretical. I like to explain things with the practical examples, and this video is like just theoretical, so I will make it as fast as possible. So I have created here a notebook where I have this great picture for k-nearest neighbor algorithm. The KNN stands for the k-nearest neighbor, right? And I will just explain why is that. So, like, imagine you have a data set with just two columns. So, for example, you have some x values and you have some y values. And imagine this is a grid, right? So at the bottom there is the x axis and here is the y axis. And then we are just plotting here the example. So for example, this, if here was 0, that's a 0 that let's say 5, and that's the class 1. So the square is class 1 and the triangle is class 2, right? Or in our case, it's the class like he will leave the company, and then this is the example of he will not leave the company. So let's just make this example simple with 2 dimensions, right? So how do we predict, or how does the classifier classifies if this given new example, the circle, is either a square or a triangle based on the 2 values, right? So the algorithm will put the example inside the feature space and it will look on the k nearest neighbors. How simple, right? So in this case, it's looking for 3 nearest neighbors. And as you can see, there is a square and there are 2 triangles. So let's say make it easy. The classifier will guess based on the k nearest neighbors, the class, by the majority vote. So in this case, the majority is triangle. So the circle will be classified as triangle. How simple. Now, the KNN can be quite inaccurate. Now, why? Because the question is, how many neighbors are we going to use, right? Are we going to use, I don't know, 10, 12? Like, it's a good rule of thumb to use the number which is as low as possible, right? And there are even other stuff which you can find on the internet recommending the number of the neighbors, but it's always a tough decision. And the decision on the number can vary based on the dataset. And now the next thing is, how are we gonna measure the distance between these guys? So there are a lot of distance metrics, and now many of you may say, well, that's simple, this is a 2D space, Euclidean distance, right? So the triangle, yes, so these one are closer. But you need to understand that when you have a dataset with 521 columns, you are going to work in the feature space with 521 dimensions. So our brain is not even possible, well, most of our brains are not even possible to like visualize the 500 dimensional space, right? But the algorithm can do it behind the scenes. And now it's tough to like count the distance inside this multi-dimensional space, right? So which like distance metric are we going to use? Euclidean distance, Manhattan distance, Minkowski distance? Well, that's a tough question, and I will show you how you can like evaluate the classifier based on the distance metric in case of KNN, and how you can evaluate the number of neighbors which you are using and stuff like this. So this was the KNN. Now let's talk about logistic regression, and the logistic regression was derived from the linear regression. So first, let's talk about linear regression. So imagine you have here we ain't gonna predict the class, but we are going to predict a value, right? So imagine here you have X, which is, for example, the number of, I don't know, rooms in the house, and the Y is then the predicted price of the house. So in this case, we are working just with one dimension, the number of rooms. And as you can see, if there is a 1 room, the price is 6. And if this is a 2 room, the price is 5. And if there is a 3 room, the price is 7. Now, what does the logistic regression? It is trying to create a line which will go through each of these examples. And then when the new example came, so for example, it will predict what will be the price if the number of rooms is 5, the classifier will predict the value on the line, so it will be around 10, right? So the logistic regression is trying to set a function, the line is called a function, to map the data set in the training data, right? So, and then based on this trained line, the classifier, in this case the regressor, is trying to predict the value based on the closest distance, right, between these, right? So the function is trying to be minimized based on the distance between the trained data. So these are the trained data, the red dots, and we are trying to put here the line which will have the smallest distance. By summing the distance, the classifier will sum the distance between the training examples, and we will try to put here the line which has the smaller distance between these. Yes, so there is a lot of math behind the scenes, right? The derivatives are applied because we are trying to find the minimum of the function. But as I said, this is not a mathematical course. So you can find explanations in the books and on the internet. But this was linear regression, right? This is predicting the numbers, but we want to predict the classes, Michal. So how we are going to do that? So the logistic regression is the same, almost the same. So let's say you have like hours of study on the x-axis, and then here is the probability that you will pass the exam. So there is only two values. There are two values. You will pass and you will not. And as you can see, by increasing the number of hours, there are more points here. So the logistic regression is trying to put here a function here which is trying to map the behavior of the data set, right? And then there is a round function applied to this function. So we are predicting, for example, if the function says, what is the probability that you will pass the exam if I study 3.5 hours? So we are almost here. So the value is here. The function will predict that there is a probability of 0.75. So 0.75 is rounded to 1. So the classifier will yield the result of 1, right? So again, logistic regression, similarly to the linear regression, is trying to map a function to the data. Now, well, this explanation can be an hour long with a lot of mathematical equations, right? You don't need to know these equations when you are applying the Python's libraries, because like the whole mathematics is happening behind the scenes. And now I don't want to bother you with the charts, with the numbers, with the derivatives on the paper. I can do a separate course for this, but this course is dedicated for those of you who just want to use the libraries in the Python, right? But I have a recommendation for you. If you want to learn something about logistic regression, there is a very nice YouTube channel called StatQuiz, and go there to logistic regression, and this guy has some amazing explanatory skills explaining the logistic regression for you. I just don't want to copy him, so I give him a credit. He's a great guy. Go there and check this out, okay? So now I hope this video give you a little bit more insight into the algorithms which I'm going to use through these examples. So we already used the KNN classifier and the logistic regression, right? If you are still confused, please write down into the discussion, and I will link you some great books about this issue and some YouTube tutorials or something else. Like, I think I can create even in the future the more mathematical course about this issue, but right now I'll stay with the practical examples. Guys, thank you very much for watching this lecture. So try it on your own, try some examples from the things which we were talking about here in the previous lectures, and I hope I will see you in the next lecture. Thank you very much.